and I'm going to go ahead and change my screen view. So you should be able to see the website. And I'm just going to, this will probably break everybody's screen if I do that, but I'll get that out of the way. Here we go. That's the new website for HADC. The link just dropped in chat. And this is the schedule. So if I make this a little bit bigger for everybody, what I'm going to talk about today is something that I hope all of you have thought about before, and you've probably already tried it a little bit, on how to use AI to analyze your data. And I want to give you my perspective on it and share with you some files that are prompt context files and give you an idea of how I think you need to prepare to do a scientifically valid data analysis, you know, the extent you have to go. And I want to tell you a little bit about some of the platforms you can use and compare some of them that are free with some of them that aren't free, and give you my view on that. If you want to follow along, you can click on the files link. And if you want to, I do have some slides I'm going to start with. If you'd like to follow along with that, you can click on the slides link. That's going to come up like this. And you can download them like that. And now I'm ready to begin using AI to analyze your data. Now, what you want to do when you're analyzing data is you want to analyze it rigorously. You've collected your data. You want to analyze it rigorously to a high scientific standard, and you want to communicate it. A lot of you working on your PhDs and even lecturers, sometimes it's not clear exactly, and you have choices. It's not clear exactly how to analyze your data. And a lot of you come to see me. You get statistical advice, and that's the best thing to do most of the time. But recently, this change has happened in our world. AI has come in, and during the time that I was off work in the past year, I made a conscious decision. I mean, I didn't have much choice in it, but I had to step away from doing my day-to-day work. And when I was feeling up to doing something, I indulged myself, and I delved into the world of large language models and AI, and I had enough time for once in my career to focus on something completely different than what I do day to day. And one of the things that I wanted to say about my discovery during that time is that it is changing so fast. It's impossible to keep up with it, even if you can focus on it exclusively. Things are changing, big things are changing week to week in the science and in the consumer side of AI. So how does that fit in with analyzing your data and communicating it these days? Well, you think about the things that we need to accomplish this. You need some data to start with, and I'll talk a little bit more about some things to consider for that. It's something we talk about a lot in here, how to get good data, how to store your data, and so forth. You need to be able to articulate what it is you want to learn scientifically. Now, most of you are able to do that because you're experts and training to become experts in your field. So articulating what you want to learn from an experiment or a data set that you have, this should come pretty straightforward to most people. Now, statistics knowledge is something that most people are on, let's call it a learning journey. And most people don't have a lot of formal training if you're in biology or agriculture or applied economics or whatever your field is. Economists actually are great statisticians. I see Carl there, and I've said that to him many times because of the math that they use in their science. But inferential statistics is something that most applied scientists have to work on through their whole career. And they usually learn it as they go along. So you may or may not feel real comfortable with this. From my perspective, had a ton too much, perhaps. No problem, Simon. I see your message. If you're still here, see you later. It looks to me like most applied scientists get what I call a first statistics class, and you get it a number of times through your career. You usually have a first statistics class in your bachelor's degree. Usually have a first statistics class again that reiterates exactly the same stuff in your master's degree. And if you're lucky, you might have a formal class. You can take maybe something like the RStats boot camp that some of you have taken, some of you may have heard of. It's also a first stats. And so you get this intro over and over, and we never really go beyond it to a place where probably most applied scientists eventually end up after analyzing your own data over some years. And then we have to pick some software to do the stuff for us. I've put R here, but as most of you know, my philosophy on this is R is just a tool. The software you pick is not really that important as long as that software adheres to best practice. And best practice these days includes your analysis being reproducible, 100% reproducible. And the best way to do that we have at the moment, at least before AI, was to code the analyses that you do so that anybody could reproduce exactly, if they have your exact data, your results. So I've kind of talked through this, but for most applied scientists, the comfort zone is down here. You're able to curate a data set, perform an experiment. You're able to articulate what it is you want to learn scientifically from your data. But some people, especially when you're starting out and you've only had that first stats course, the stats knowledge you're a little bit weaker on, and people who haven't used R before, it's a steep learning curve. There are some things I've left out of here, and I'm just going to ignore them for the purpose of today, but we talk about this kind of stuff a lot in our meetings. One is the practice of curating your data in a tidy data format, tidy data in double quotes as a concept in science. A lot of you are aware, we've discussed the Hadley Wickham's tidy data paper, where he describes how to curate your data in this format with a dictionary that explains all of your variables so that it's useful for someone else. Turns out the tidy data format is really, really useful for AI as well. So we have this. If you're new to this, this is a good and easy tool to put in your toolbox. We also, I'm assuming here, that we knew something about the experimental design. Let's say, for example, determining how much data you should collect. You've determined, maybe by doing a power analysis, the sample size you need, and I'm assuming that your data set is sound in that way. And also over here, really before you collect that data, best practice is to create an analysis plan. I know in the first year report, there is a place in there for master's students and for PhD students to communicate your analysis plan. And if I'm involved in those, it almost always must involve a power analysis, but most of them don't. And, that's okay, because at Harper, we have a statistical consulting service, which there are a few of us now doing this, and I'll join it very soon. I have an outstanding email to answer, and I don't see the person in the chat, or I would just apologize that I haven't answered yet. But if you are here, I'll answer you tomorrow. So this is all going on. And what I want to suggest to you is that if we consider the learning of some software, best practice software involving code like R, could be Python, but R is still the best tool for inferential statistics, and it will be for a while into the future. Now, this problem of learning to code can be solved fairly easily by most people with AI. And what I'm going to show you today, I hope it demonstrates it clearly, that the stats knowledge, you can also solve this with AI, but it's a harder problem. And I actually think that we have to plan very carefully, and that for most people beginning their statistical knowledge journey, let's put it like that, that you probably would still benefit from statistical consulting support from your supervisor or from a statistician in able to communicate this effectively via AI to get the results you want. Okay, so I guess what I'm saying is that we hear a lot about a lot of jobs going extinct because of AI, but I'm not worried whatsoever about my job. All right, so we're going to talk about some solutions. Um, how do we get at this? And I've got a couple of demos set up, which I hope we have enough time to get through all of them. I have quite a lot set up that we can go through. We'll see how many we do get through. Well, one way is a way that I refer to as AI bros. What do I mean by AI bros? I mean, there is a scramble. And when I say scramble, I mean there is a real global scramble for entrepreneurs or engineers that are entrepreneurially minded, let's say, to create solutions to problems that people have or problems that they can persuade people that they have. These One example of this kind of problem is the automatic generation of social media content. And the an AI bro is somebody who would use AI generated social media content to advertise their prowess in creating an AI solution to creating automated social media content. This is a perfect example of an AI bro, and they're very common. And I guess my point of being slightly disrespectful to those entrepreneurs is that a lot of times they're solving a problem that's not quite the problem you have. And for applied scientists who want to do inferential statistics, this is a fairly niche problem. If you want to do simple statistics, it's probably the case that you don't need AI at all because you've all had that first stats class. And so you probably want to do some advanced models. I've said it many times in here that I think the minimum stats knowledge that a PhD student working today in any of the broader biological sciences, applied biology, agriculture, even economics, is you need to know about mixed effects models, and you need to know about the generalized linear model that can handle data other than Gaussian data, other than normally distributed data. So I've got an example today of that kind of problem, and we're going to test out some AIs. And my point here on the AI bros is that that's a pretty niche problem, advanced statistical models for applied scientists. And there really are not very many solutions that are tailored to that audience. Probably because the audience is niche and very small, and the other lower hanging fruit is being solved first. You have lots of options is a challenge when you're trying to pick exactly how. You have options in the terms of which large language model. Can I take a survey in the chat? Can you put a 1 if you know exactly what I mean when I say large language model, and maybe a 0 if you're not exactly sure what I mean when I say large language model? Could we just put the 1s and 0s in chat? 1 if you know what a large language model is. Yeah, I see some 0.5s is a good answer, some 0s. Okay. So what I mean when I say large language model is I mean ChatGPT is the best example of a large language model. So these AI tools that we use are based on a kind of model called a large language model. What does that mean? Well, the inputs and outputs are in human language. It's the language part. The large part refers to the fact that they're usually trained on lots and lots and lots of training data, like most of the text that's available on the internet in the case of Chat GPT. You have lots of options. There are many companies besides Chat GPT, but many people probably haven't even heard of them or encountered them. So Google has a large language model called Gemini, and it's very, very good. And it recently has claimed the top spot for solving coding kinds of problems, Gemini 2.5. A big company that's a competitor, it's much smaller than OpenAI, the company that created ChatGPT, is Anthropic, and their model is called Claude. So Claude Sonnet 4.5 wants to be the best coding model and maybe is a little behind Google at the moment. And OpenAI, of course, has ChatGPT, and they have lots of options for their models. And The latest one is Chat GPT 5, and there are versions of 5. And as you'll see, if we get to this in the demonstration, when we look at the free version of Chat GPT, they simplify it for you, which is a good thing. They don't allow you to pick which version of their model. They pick it for you based on your question. So we're going to test that and see how that performs. And well, what is best practice? Well, really, I'm going to tell you today about what I think best practice is for using large language models for statistics. And I'm fascinated in using AI for my own work. I'm interested. I'm interested in whether it can make me faster. I'm interested in is it can I do better than the model? So I thought of it like this. If you know the American folk story of John Henry, I thought I'd do a little test where I test myself on a data set, see how I do, which I'll walk you through on a an advanced model, but nothing too complicated as far as the data goes. So I picked the data set, I analyzed it completely myself in the simplest way that I could think of, and I also created a report from it. And I'll walk you through what I did first, and then we're going to compare it to what the machines can come up with. So I have a couple of demos that I'm going to go through. One of them is me um, manually analyzing the data, and I'll just tell you that that took me about 45 minutes to create both an R script and a report script. Now, both of these can be improved. There can be a lot more to them, but I think both of them would be adequate for a regular experiment involving this kind of model to completely get all the good information out of the data set. Then I wanted to compare best practice for AI to analyze exactly the same data set. And as I'll mention when I show you what I've done, to prepare best practice for the AI large language model, it took me about 45 minutes. I was pretty pleased when I timed myself that it took almost the same amount of time. Now, the analysis itself only takes a minute or two, which I will show you. But at preparing in the best practice way to get that good result, um, only took, it took me full 45 minutes to prepare the prompts. And then I also want to prepare a naive prompt. It only took me about less than 5 minutes to write a naive prompt, the kind of prompt that you might just use if you rock into ChatGPT and you just want to see what it can do with your data set and you upload your data. So we're going to test how those results work out. So first of all, I'm going to do a demo of my analysis. As most of you know, I love using RStudio, and so I'm going to use RStudio today. I'm going to close this and reopen everything so that we can all experience it together. And I'm going to clear my console. There we go. So I'm going to open the file. First, I'm going to find the file on my computer so I can just paste that in. Whoops. Okay. I'm going to open an R script that looks like this. And I'm going to make this a little bigger so it's easier for you guys to see. There we go. That's probably good enough. I'm going to clear my global directory here. Now, you guys who have been to these meetings before know that I have a way I love to set up my script. I'm going to point this out because it is relevant to using the best practice for AI setup. I have a header that says who, when, and what. I have a contents page. The content page allows us to browse in RStudio. And for me, this involved data prep. The data set that I picked is from a package called Agricoli. It's the CHZ 2006 data set, which is about um, potatoes that are infested with a pest and they experience rotting. And there were several sections to this data set. If I just load up the data, we can look at it up in the global environment. You can see it has a wilt section and a yield section, and these are two different experiments that were done. And what I've done here is I'm just choosing the wilt part of the data set. This is almost 2,000 observations. And let's just look at what the wilt data set looks like down in the console. You can see, oh, my head is covering the console. Hold on. Let me just fix that. I'll remove my head from this conversation for just a moment. There we go. What you can see is that there's an amendment factor, which is the treatment, which we'll look at in a second. And this is inorganic fertilizer, I think. And then there's for the rotation, there are different crops that preceded the tuber crop. So pea, fallow, maize, there's a few of them. This experiment has a blocking treatment. And then there's a factor, a blocking factor. I think there are 4 levels. There's a individual plant within each block. And then there's a wilt percent, which is a measure of the infection. Now, if we look at the, I guess I'll leave my head off for a second while we look down here in the console. If we look at the names, we just see those names. And if we look at I'm interested in the dependent variable, which is the wilt percent. And I'm just going to make a table to evaluate that. And it turns out there's only 2 values, 0 or 50% wilt. And so in my statistics brain, I immediately identified this as a binary, it's not a percentage, really, it's just binary, 0 or 1. There's a presence of a 50% infection or there's 0. This is just the phenotype of the infection, if you want to be technical about it. So then I realized that, I need to turn block into a factor. So I'm doing that. I need to turn the binary. I could have left it like this. R can handle binary factors that are of just 2 different values. But I went ahead and changed this to 0s and 1s. And if we just want to look at that, there we go. So we can see it's the same. So I did a little bit of exploratory data analysis. I did the bare minimum, but I did it the way that I like to do it when there are 2 factors. So I'm just treating the binary variable like a factor. I'm going to turn my head back on for this. And we'll be looking over here in the plots window when I make the first EVA plot. This is a mosaic plot, 3, 2, 1. There we go. This is the rotation crop. So cabbage, corn, fallow, and pea. And this is the wilting present or absent. And you can see that there is a little bit of a signal here. If we treat cabbage, and you'll know when you see the table that doing a generalized linear model, I've chosen to do this not in the traditional ANOVA table way, but in the one that's more typical for this kind of analysis where I use a contrast table. So what we're going to see is a measure of whether each treatment for rotation crops subsequent to cabbage is different to the baseline one. And in this case, the baseline one is the cabbage one. I could have compared this to fallow and changed that and made fallow the baseline one, but for this simple analysis, I didn't bother doing that. We're also going to look at the amendment, 3, 2, 1. We can see that without any amendment, the 0 treatment, there's a higher wilting percentage compared to the others. So it looks like there's definitely a difference here. If I just go back to the rotation crop, not sure here. There is a little bit of a pattern, but we're comparing to cabbage, so there's not much of an effect. It's much weaker. And then last, I just wanted to look at the block. And the blocks are all pretty much the same, which it's a good thing they are because we're not really interested in block. Block is a thing that we do to control for spatial variation in experimental designs. There's only 3 blocks. Couldn't remember that. So my statistics brain has told me already, just looking at these, the data set and looking at the exploratory data plots that I made, listen, I want to perform a linear model that's multivariate. I want to include amendment, and I want to include the rotation crop. But also I need a mixed effects model because there is a little bit of an effect in block. I could ignore that and do a traditional model, but really the correct way of doing that is to statistically control for block by treating it as a random effect in a mixed effects model. So here I'm going to do a multivariate mixed effects analysis with block as my random effect and fixed effects or amendment and rotation crop. And I'm going to use a logistic binary model family because it's a binary dependent variable. So this is an advanced statistical model in the sense that you sometimes don't get this stuff in that first statistics class. But if you've hung around and been to a lot of these meetings, if you've seen I used to teach the master's stats course here. I think that linear mixed effects models and the generalized linear model, which would include other models than Gaussian, is the minimum that applied scientists need. So this is an advanced model in the sense that some people might not get it in their first stats class, but it's something that's very common. I see this exact kind of model many, many times in agriculture PhDs and master's projects. All right, so what about my analysis? Well, in R, just in passing, I'll mention that we have the LME4 package, which is the linear mixed effects fourth version of it. And this is the statistician's preference. And if you have listened to the times we've used this over the years, you'll remember possibly that this is made by statisticians for statisticians, the LME4 package, and it doesn't give you p-values by default because a statistician doesn't need any stinking p-values. What we need is a confidence interval around your estimated effect. So because most of the people here are not statisticians, I've included the gentler version of this, the LMER test, which gives you your p-values back. And then I run the model. My model is specified like this. We've got our binary variable crop, and amendment is fixed effects, and random intercept with the block random effect. I'm going to run that, 3, 2, 1. We're going to look at a summary. This is going to look slightly ugly. I won't apologize too much because I love it. There we go. We're just going to focus on this part of the table. This is a contrast table. And first I'm going to back up to the rotation crop. And what we can see is that the corn relative to cabbage is not significantly different. The fallow relative to cabbage, we have a statistically significant effect, but it's small. The estimate is small, 0.8. And the P is not significant. Okay? And if I look at the amendments, I'd be really surprised if all of these weren't significant, and they all are significant, and they reduce the proportion of or the probability of the wilting phenotype, so the probability of disease. I did go ahead and calculate the standard errors because I like to see them, but really this contains exactly the same information as the table. This is what you would get by default in a LME4 package where you get the estimate. And yeah, that's a good question. You got a question about why did I decide to do amendment plus crop as the main effects, and I decided not to include the interaction effect? It's a very good question. The simple answer was I was trying to go and do it as fast as I can for the simplest correct model. And it is definitely possible that crop by amendment is an interaction effect. In fact, we could just test it real quick and have a look at. Actually, I'm not going to take the time to test it. You can test it yourself because I want to get onto the AI part. But I did it because I did it for a specific reason. It is reasonable to just test it, but unless you have a good reason to expect an interaction effect, a significant interaction effect, it's best practice not to test it unless you have a specific prediction. I did not have a specific prediction, being fairly ignorant about the data set, and so I didn't do it. And really, it was just the simplicity of it. That is an excellent question, though. And then lastly, I used a package that's really nice. You use mixed effects models called SJPlot. It is my new go-to. It's fairly new to me, but it plots the corrected effect sizes for mixed models. And so these are the kind of plots that I would want to see. And they look like this. And these are so nice because it pulls out the predicted probability of infection for each of those effect sizes and compares them. And you could gussy up these tables by putting which ones are significant. So in this one, only the fallow is significant compared to cabbage. And in the amendment one, you can see really clearly here that they're all significant, all the amendments. And they seem similar in magnitude to each other. So if you were, wanting to resolve which amendment was best, well, you'd probably do what Von Guy has suggested and go ahead and do the interaction effect, but I didn't do it. That's my whole analysis, by the way. I did a report as well. For the report, I don't want to shock anybody with this next part, but my preferred development environment these days is no longer RStudio. I've changed and I've gone with one called Cursor. I started using it in the last 6 months, and it's so good that I just love it now, and I only use it even for R. I want to go to Cursor because I want to go here, and I'm going to compile my report in Quarto so we can see it. Let's see here. I think I might be able to see a preview without having to compile it. Let's see a preview. It's thinking. It's thinking. So I made a Quarto Markdown document in this report. And I made it so that it comes out with an HTML version and a PDF version, which we'll just briefly glance at both of them. And I made it so that it looks like the previews, it's still thinking. There we go. It's given us a preview. Now this will be very small for you to see, and I'll bring the PDF up in a second. I just wanted to show you what it is. I've got a summary. It's got a table of contents over here, an intro that talks about why we made this report, data, table of the data, what the analysis that was chosen was, the main results, which is the table and the two diagnostic graphs, the reference, which is a reference for the data set, and then an appendix, which talks about all the packages in the R version I have. This is a minimum best practice report that I think would be suitable for, master's and PhD students. We'll look at the report PDF as well, just briefly. I'm to drag it over as a PDF rather than the preview. Just navigating. Bear with me. Here's the report. The report is just like a lot of PDF reports. It's got the same content as the website version, including the ref and the appendix. Okay, so I've automated that. It took me 45 minutes to write both of those. And so I want to test it. I've just closed my my slides as well, I just noticed. So I'll open those again, and we'll go to the next demo. Okay, so the demo 2 is what I'll call an informed analysis. And then this will take very much less time than the first one. Now, an informed analysis is going to involve telling the large language model, telling the AI what I want in very specific detail. And I'll just walk you through a little bit about what that looks like. And I've made these files available to you via that link for the files. You can navigate to them on the GitHub page. I'll just show them to you on GitHub first. So this is the link to the files. The analysis ed files that I just showed you are here. And the informed analysis files are here. So there, you can see there are quite a few files here. What the heck is in these files? I'm going to show them to you in my preferred IDE when I'm going to run those files. So I'm going to go back to cursor, and I'm going to open a folder, and I'm going to open this LLM test. I'm going to select that folder. And before I walk you through what's in the files, I'm going to let this just crank up here. What I'm going to do is I'm going to bring up my minimal prompt here for informed. Now I've done the prep of these files, and like I said, it took me about 45 minutes to prepare these, and I'll show them to you in just a moment. Once you do that prep, you can use a prompt that's like this. So I want you to analyze my data, expect as output a script.r and report.qmd. QMD is a Quarto markdown document. That's what's used to make the HTML and the PDF version of the file. It's actually, I think it's the easiest and best way to write automated PDFs at the moment. There are other options if you're interested in that kind of thing. We can talk about it. Further instruction, check out prompt.markdown. So that's my prompt, which we'll look at in a second, in the files folder, along with my data file and other files in there for the full prompt. Tell me your name after reviewing all the files, then begin. I include this tell me your name because in those prompt files, I have informed the large language model that what their name is, what I am telling them their name is, and I want them to tell me their name back so I'm sure that they've actually read my prompt files. So this is just a little hacking test that I put into all of my prompts. So I'm going to copy this in cursor. Over here is a file menu. Up here is this is where your folders and file navigation is. Here is where your code files will be. We'll look at the prompt files in a second here. Down here is a terminal. This is similar to the R console, and you can actually get an R console in here if you set it up to have R, which of course I have. But over here is where you interact with the AI, and that's where I'm going to put that prompt. And watch what happens when I do it, and let's just see how long it takes. 3, 2, 1. If you read quickly, I'll just make the bigger a little bit so you can read some of it. It tells you what it's doing, but it's in gray, so it's going through this rather quickly, and this isn't any result. So now the white text is what it's done. It's told me its name. I've named it R.A. Fisher, you worm, just because I think that's mildly humorous. I hope you guys know, some of you will remember who R.A. Fisher is, the greatest statistician that ever lived. So it's telling me it's going to create the statistical analysis, which it already has. Now it's working on the report.qmd. Took about, a minute to produce the R script. We'll look in it a second and see how close it came to my analysis. Now it's finished with the report. That took another minute or so. And it's checking for errors. It's done. It's completely analyzed. It's completed the analysis script and data prep. It's created some exploratory visualizations. It's done a mixed effects logistic regression model using GLMER, a different model than a different library than I used, but one that's appropriate. It's done a report.qmd, a brief professional report. Let's just look at what it's done. I'm going to make this a little bit smaller so it's actually easier for us to see what it is. Let's look at the script first. So I gave it a template, as you'll see in a second. I'm going to keep everything. Don't save. So let's look at the script. So I gave it a template that told it to do it the way that I like to set up my scripts, as you'll see. I didn't tell it anything else. It did load up, interesting, it loaded up the LME4 library. It's read in the files, knows where they are, because it looked there for them. Did a little EDA, exactly like I did. It created explicitly named factors. This is actually best practice that I didn't bother doing because I know how R treats factors in linear mixed effects models, and it's unnecessary to do this, but this is technically more correct than me just knowing and exploiting how the system works. It's created with an if-else, the binary, so it did it in one line instead of the 2 lines it took me. It's used ggplot to create it. Let's go ahead and run it and just see what it comes up with. Actually, I would rather not run it in Cursor because that takes some, it's going to take more time, and I want to get to the last demo. Then the analysis, it's done a mixed effects model. It's really exactly the same as the model that I chose. Of course, I've told it that with specific language in my prompt, and I didn't tell it how to do it. So it's done it exactly correctly with a different solution than I did. Got the summary. It's provided an ANOVA table rather than a contrast table like I printed via the CAR package. That's a nice step. I considered doing that too, but just didn't do it. It's using EM means to look at the contrasts between the different levels. This is a little bit like looking at a post hoc test. We'll look in the report to see what the solutions were here. Get a preview of the report. We'll get a glimpse at the HTML. Maybe I need to compile it manually, which I'll just go ahead and do. Didn't like something. Let's see what it didn't like. Okay, it didn't like it because it's chosen solutions that I don't have installed locally. But that's okay. What I see here in the script is that I'm not going to take the time to problem solve that at the moment because we don't have much time left, and I do want to get to the last demo. But it's done the model completely correctly. It would be nice to look in the report and see it, but it will have put exactly the same things, just like I did when I created my report file, and it would print out if we just load those libraries. And by the way, because you have these files available, please play with this and load those libraries up and, compile this yourself in R. And if you're interested in learning how to do that, we could do that in another session. So just let me know if you'd like to do that. That would be no problem. I want to go back to my slides. That was an informed analysis that took me exactly the same amount of time to set up. But the thing I wanted to show you before we move on is if I close these and close the script, I've created a prompt file, and I invested 45 minutes in creating all these files, including the templates. And the idea is that I could recycle this, and the only thing I'd have to do for my next analysis is tweak information about the data here, give information about what the dependent variable and what the factors are here. And most of these instructions don't even need to be changed now. I say that I want a script.r to be made and a report.qm to be made, and to use the templates. Because I've already made the templates part of that 45 minutes, I don't have to remake them. I'll get my next completely different analysis in exactly the same format. Told it to avoid extensive exploratory data analysis, although if you want it to perform rigorous exploratory data analysis, you just need to change a few words. And because up in the data, I did prescribe using a mixed effects model, I just reminded it to use a specific kind of model, mixed effects logistic model. So I've given it quite a lot of information because I have the knowledge to do so. And I would just need to change this instruction. Now, a thing you could do, if you wanted to recycle my prompt and my guidelines, we look at my guidelines, these are just general instructions that won't change for any statistical model. I've named the agent so that I can come back and test. I can say, listen, tell me your name, so I can test whether it's paying attention to my instructions. And of course, I knew it would. And I've given it very general instructions for any analysis here and the style that I want. And it's done that. It does it correctly repeatedly. It's about the 4th or 5th time I've run this. And the template for the outputs is included. So the templates are just like the script and the reports. Let me just show you the script, and you can look at them yourself if you're interested. It just doesn't have any actual detail. It's just an example code of what I want and some comments about what I want in there. Demo 3 is a naive analysis, but before I do that, because we're almost out of time, I wanted to just say, listen, you've got lots of options. The one that I'm going to demonstrate now is ChatGPT, but Microsoft has their own Copilot. Eventually, universities will all buy and all companies will buy Copilot for their companies, but at the moment, Harper has not bought Copilot for us, and my colleagues at other universities tell me that their universities are cheap too and haven't bought Copilot yet. Eventually, though, if you use GitHub or if you're an educator, you can get access to coding Copilot for free through an educator account. So that's a free alternative to the paid alternative. And I should mention that I didn't show you this when we did it. I'm just going to make this a little bit bigger. In Cursor, for the model here, way down here, you can see that I'm using a particular kind of model. I'm using Claude Sonnet 4.5, which is my preferred code model at the moment. If we do have Copilot, I haven't experienced how we can use it, but I'll take your word for it. You probably know better than me, Joe. That's interesting to know. Okay, that's interesting to know. I'll have to check it out. It also has this little brain here, and the brain is max mode, and that means that I pay a little bit per month for Cursor. It's around 15 pounds a month, but I get access, quite a large access to these. And there is a free mode. The free mode's a little stingy, and you won't be able to use the brain mode on the free version of Cursor, but if you're interested, check it out. Prompting and context, that's the files that I just showed you. Are they real skills? They are real skills, and we can't take them for granted. If you want to get the most out of AI and prompting and creating the context in text for what you pass to the AI, you can't ignore this if you want to get out something that's worthwhile. So I've like I said, you have access to my prompting and context files that you can edit yourself. Try it out in the free version of Cursor. I have this table. I wanted to just point this out. I'm not going to go through it, but I've compared, in my experience, GPTs and large language models that I've actually tried. Cursor is the one that I think is the best. It's going to run your code, and you're going to get, if you prompt it properly, you're going to get research-worthy output. ChatGPT Pro, I'm not going to demonstrate that today, has an advanced data analysis mode that's made for data analysis. It also will do this analysis correctly. Windsurf is just like Cursor. It's got a more generous free mode than others. I have only played with it. It's similar to Cursor, and it also will run your models correctly. You also have a choice of which model you pick. Vanilla ChatGPT, we're going to test it out right now. It can produce really good code, but you need to tell it exactly what you want. Notebook LM is a product from Google that uses Gemini. Their free mode it doesn't produce good results. There's only one of these products that says that it's been made for data analysis, and that's Julius AI. There are a few others out there, but they're not as popular. Julius AI is the most popular one that says it's for data analysis, and it does simple statistics pretty well. If you only needed to do simple linear regression, one-way analysis of variance, it will do it, and it will make graphs that are really good. They look aesthetically pleasing. The free mode is very stingy on it. It promises the world, but it really only delivers in simple stats, and it's not really reproducible. It's a black box, so I wouldn't recommend it, at least at the moment. Especially not if you're thinking about paying for it. It's not worth it. So let's go to that last demo I wanted to do. I've got a naive analysis. You can look at the prompt. I'm just going to go ahead and open this in Notepad. And this is my naive prompt. I'm going to make it a bit smaller. And here's my prompt. Make it a bit bigger. So I say, here's my data. Here's what my data are, where they came from. Say amendment and cropped are factors, the explanatory variables of interest, and block is a blocking factor. And I don't tell it what kind of model to use. Here are the instructions. Analyze my data using an appropriate statistical test, producing R code in a downloadable R file. I also want a summary of my results in a report form with the results of statistical tests and appropriate graphs, along with very brief accounts of background and statistical methods in the analysis. This can be something I can copy and paste or else download the file. Avoid extensive exploratory data analysis. So this is a fairly naive, anybody could produce this. Undergraduate students should be able to produce something like this, and anybody else. I'm just going to copy this. Got a special window open, which I will try to find. And this one, which I've created a free account. Notice up here we don't have a choice of which ChatGPT or the advanced data modeling is not available here. So I'm going to add in my prompt. And I'm going to add in my data. Let's see what it can do. It's thinking. I know that because this has got a stop button. Let's see how long it thinks. Now, it probably at first took some time to pick which model it's going to use. And I'm not sure that this free mode will tell us what model it eventually takes. Okay. It's going slow a little bit. Okay. We'll assume the dataset .csv is available. I did upload it here. It doesn't actually need to do it. The advanced data analysis mode can actually run R and Python code, whereas this one can't. So I guess it doesn't need to run it. So that's why it's only tipping the hat at the analysis. Still analyzing. No problem, Sarah. We're right on the hour. I know some people will have to leave, but if you want to stick around, feel free. I'm going to see the end of this results. I won't have it go over very much. So if you're new to the meetings, I like to start promptly and meander in the things that I say as little as possible, but I find that difficult at the beginning of the meeting. And I like to stop as close as I can to the time of 5 p.m., but we're going just a little over tonight. It's probably worth the wait just to see the results of this. Still analyzing. Now, this is another thing I forgot to mention about the free versions of ChatGPT, is that Sia Claire, is great seeing you, is that the speed of the analysis is also something that you pay for. Jimmick, it's very sad to hear you might have used up all your tokens for the day. That's really terrible. I could lend you some. I would gladly lend them to you if I could. still analyzing. So that this, I think, is a fairly straightforward problem. Maybe it is looking in the CSV, maybe not. Yeah, then you have some extra tokens sitting around. All right, let's see what it's doing. Still thinking. So this is taking, as you can see, far longer than than um, than the other versions, which were very speedy. Part of the reason is because I was using a paid version of Claude Sonnet in my cursor. I probably should have switched it to ChatGPT. One nice thing about Cursor that I like is that you get access to many models without having to pay for each one of them individually. Another nice thing about it is if you do pay for ChatGPT, can use your own ChatGPT tokens in Claude instead of using up your Claude tokens. And by tokens, what I mean is the amount of text you put in and take out are measured in units called tokens, and it's how many tokens that the payment relies on, and how many you get for your account. Okay, incomplete task delivery. It looks like it wasn't able to provide the output, and there's been a timeout. So it's still thinking and analyzing. Now I'm surprised if the free ChatGPT can't give us some result. So this is very interesting to me. This is one I've tested least. I've mostly played around and done experiments trying to see what is required to get the actual outcome that I want and need. All right, it's analyzed it, produced an R script. Number of observations, this is all correct. So it's analyzed a linear model, and it has analyzed the interaction effect, but it's analyzed block as a fixed effect, which it clearly isn't. We don't care about block. This is not really a valid result. So we need to consider block as a random effect, especially since it determined that block is significant. So there is a difference. That first block had a little bit more wilt than the others. And let's see, we do have our analysis script. Let's download it, have a look at it. For this one, what I'd like to do is I'd like to download the markdown, and maybe people want to spend 5 more minutes, I'll just compile it and we'll look at the report. Let's see, where do I want to put this? I want to put this in HADC. Put this in. Go ahead and make this available to you too. I'll put it in files, today, and the naive. There we go. And then I'm also going to download the report and put it in the same place. I'm just going to grab that URL, copy, save, back to cursor. Open a folder. Got our R script. So it's loaded up lots of packages. It's read in the CSV. It has done the model differently, and it's not really correct the way that it's done the model. It's not, but it's not an incorrect model in as far as it will run in R. But it's statistically not a valid approach to treat block as a blocking variable. So it failed to do that. Oh, it does have a mixed effects model in there. So it does have one, and it does have one. Oh, that's very interesting. So, hey, it did it on the free model. And we've got a plot of, let's see what the plot has got. It's a facet wrap looking at the crop groups, the wilt percent, and the amendment. So it should be several panels looking at that, and that's a nice way to do it. So let's look at their prompt. I'm going to bring up my terminal, see what they've got. See if this will do it. I'm just going to give it one shot to see if I can get it to compile. It might be better to just do this with a preview. I think it will be. If it'll play along. There we go. It's coming up with the website logo because pop that out so I can see it here. It's coming up here before because I've compiled this in the website directory. So it didn't do a great job on the report. It doesn't have any of the contents of the report that we expect. So back to this. ChatGPT, I would change this on this test to a red dot. It just didn't do what we wanted to. Maybe amber is still fair because it didn't give us the report we wanted, but it actually did come up with a fairly good script. And if you were to have a conversation with the ChatGPT and ask, hey, I've got this blocking factor, and notice you've got two different models. Because I don't care about the blocking factor, which model should I do? I want to statistically remove the effect. Probably if you build a block into your experiment, you, or at least your supervisor, would definitely know that you want to treat that as a random effect. And you definitely should get the advice from the ChatGPT if you ask the question I just posed to choose the mixed effects version of the model it wrote. I'm pretty impressed that it wrote a good R code, but I am disappointed with the script. Of course, if we did a informed prompt on vanilla ChatGPT, we probably could get a good result based on that experiment. I didn't do it before because it was taking so long to test both of the prompt types side by side. We're out of time. I'm going back to HeadCam. That was really fun. Are there any questions? I'll answer any quick questions, but I want to end pretty quick because I don't like going over very much, and we're already 8 minutes past. Any quick questions? What I plan to do while people are pondering questions is I'm going to send out a recurring invite. I didn't take a survey when I started this meeting, but I picked Tuesday because Tuesday afternoon is great for me, but I didn't ask anybody else. I was going to take a survey. I can't do Wednesday afternoons anymore. We used to do them on Wednesdays, and then I understand for a while they moved to Thursday. I don't like Friday as a day. That's also a great day for me, but it's right at 4 p.m. on Friday for some advanced stats. You know, that's like most people are not thinking about statistics a late Friday afternoon. Is there any objection to Tuesday at 4 p.m. for now, and we can adjust it later? Speak now or forever hold your peace. Put it in chat. So good to see everybody. Thank you for coming. And I'm assuming that this has been recorded the whole time. I'm a little out of Teams practice. I did see that Megan, thank you for starting that, started the recording. So this should stop after we do. All right, got 1, 2 people that agree with Tuesday. That's great to hear. I'll see you later. It was great seeing everyone. I hope to see more of everybody soon. Iona, thank you so much. And I'll see everybody later. I'm going myself to think of Friday afternoon thoughts, and I'll see you later.
Great to see you again, and see you later, Ed.
Thanks so much, Emmett.
Cheers, Ed.
See everybody later. Bye-bye.
Thank you. See ya.